Alright, you guys. So for number 8, it's a pretty creative problem and not that hard once you grasp the concepts, alright? But it's definitely more on the creative end. So for number 8, it is worth 7 marks. And they tell us that part of the function f is shown in the following diagram. So this whole thing that I have drawn is function f. The graph of y equals f of x, right? So this whole thing is basically f of x. They tell us that it has a y-intercept at 0, 3, which is right there, of course, and then x-intercept, okay, an x-intercept at a, 0, so at some x, 0. And the horizontal asymptote, I'll put this in a different color, at y equals -2. Now, you guys, an asymptote, just a quick review, an asymptote is basically a value that your function never touches. Note, it does get very close to it, but it will also never touch. So it gets very close, but it never touches. And so a horizontal asymptote, okay, that means you are drawing a horizontal line. So horizontal asymptote is basically just horizontal line, and that is why we also mark it with a y equals. And I know that might be a little bit weird. You might be thinking, yo, wouldn't the horizontal thing be associated to x values because x is my horizontal line? And I say, yes, you're right. But in this case, if you want to draw, this is the thing. If you want to draw our horizontal line, we'll take a moment and look at it. So this horizontal line of -2 right here, this y equals -2, which is the one they're telling us here. So this horizontal line, take a moment to think about it. For example, this point, this point, this point. And so this point here is around, well, we actually don't know the dimensions of our x, but I'm just going to make up that that point is -10, comma, -2. This point here is, I don't know, like -8, comma, -2. Oh, that's interesting. And this one is -6, comma, -2. So these numbers are made up because we don't know the dimensions of the x grid. But notice these 3 points have a -2 for y. And so that is why for expressing a horizontal line, you would say something like y equals -2. Okay? That is why in decimals, if you put y equals -2, it looks like that. And if you put, for example, x equals 4, it looks like the one that's purple. This is because all your x values are 4, while for the horizontal one, okay, all your y values are -2. And so it's just a quick recap, you guys. Horizontal asymptote, y equals something because one y is always going to be the same. While for the vertical asymptote, x equals something and that x will always be the same. Okay, in this example, x equals 4 looks like that. Your value of x equals 4 does not change, your y does. So, enough blah blah. Let's now get into more of like the core of the exercise. And so for part A, what they tell us is something a little bit weird. They tell us to consider the function g of x equals all those symbols, which I will go over in a second, but it's a bunch of symbols, it's a little bit weird, and that on the following grid, we need to sketch the graph, okay? And now I know some of you, or at least it used to happen to me, like, sketch the graph, easy peasy, easy points. But careful, sketching this graph is worth 4 points. And so for sketching, it is very important, you guys, that you consider key points. Key points. That you consider, for example, asymptotes, okay? That you consider intercepts, okay? And that you consider just like how it looks like. Okay, usually if you consider these 4 things, you will get those 4 points, okay? And I'm just going to show you right away in the mark scheme because I think it's important to know how they like evaluate these sorts of exercises. For example, this one up here is literally the one I said about like it looks like correct. See? This one here is that asymptotic behavior is making reference to, you know, you get the right asymptote. This one over here is basically, well, you put a maximum at 0, 3, so that would be definitely an intercept, right? Well, actually, more than an intercept, it's just coincidence, but it's more of a key point, right? You're putting the maximum. And over here, you have, again, asymptotes and oh, here actually, sorry. Here you have x-intercepts. See? So, although it's worth 4 points, don't do the common mistake of just drawing what it looks like. Make sure you label your graph. Okay, this is going to be your favorite word for this exercise. You want to label your graph. And actually, it tells you to label any axis, any intercepts, blah, 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 blah. See? So, just a kind of reminder that whenever you see sketch, yes, it's relatively easy points, but do it correctly. Label everything. Put the intercepts, put the key points, put the asymptotes. Make sure it looks like how it's supposed to look like. Okay, nailing how it looks like is only one of the many points you can get. So, how the heck does this look like? Well, our function is, and let me write it up here. Our function is g of x. This is what we need to sketch. So g of x, and they tell us that we need to do the absolute value of the absolute values of x, which is kind of crazy. See, so first things first, what is an absolute value? So an absolute value, okay, so absolute value, and I'll be putting that thing, see, so like it's basically like a wall, okay, or a straight parentheses. Think about it however you want. See, but an absolute value is those straight lines that I have in pink down here. See, so those straight lines, what they tell you is that you're dealing with absolute values. Now, the absolute value, what's the cool thing about it? Absolute values, okay, which look like that, make whatever is inside positive. Okay, so if you ever have, for example, the absolute value of -4, your answer is just going to be 4. If you have the absolute value of -3, your answer is going to be 3. If you ever have the absolute value of 2, it's going to stay as 2. Okay, so stick to the intuition that absolute values makes whatever is inside positive. Makes whatever is inside positive. And so, having that in mind, you might be thinking like, oh, okay, so if I need to make everything positive, all that's really gonna change in my graph, and you would be partially correct, all that's gonna really change on my graph is noticing, okay, so here I have negative values, so all I really need to do is sort of like make it jump back up, see? And you would say, okay, here's my sketch. And you would be almost correct, okay? What you graphed just now, okay, what you graphed just now, which is in green, all right, so forgetting this thing on the bottom, what you graphed just now is really this. And so careful, there's a small difference that I need to go over. Technically, there's 3 variations, so let me explain all of them one by one, just so that we go over everything that can happen to us. So this one that's in orange is both x and y being positive. Well, this one in green, which is what I graphed actually, is only y is positive. Well, this one down here in purple is actually only x is positive. Because notice the example that I have in green, which is one guy that goes like this, so boom and then boom, you still have a bunch of x values that are negative down here, right? And so having that in mind, you guys, okay, having that in mind, what you need to do is think about the corresponding y value, okay, for orange, right? For the correct answer, you need to think about, okay, so this x of -1, for example, is really going to be an x of +1, and what is the y value of that? See? Now, I know that sounds pretty much insane, so let me show it to you more visually, okay? So, because your original is, yeah, okay, I'll do that way. So, because your original looks something like this, okay? That goes boom, 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 touches, and then keeps going down, see? because your original looks like this, okay? And actually, let me put it in red just so we understand that this is my function. So this is your OG, right? Because you have absolute values on the outside and on the inside, that means that both your x values and y values are being affected by the absolute value. And so on the one hand, first you can consider the transition of having no negative y values. See, so if you make no negative y values, well, it has to look something like this. So if you have no negative y values, when you reach that famous a, right, when you reach that famous a, it's just gonna like sort of bounce back up. See? Now it bounces back up, having in mind the asymptote from before. See? So if here you have -2 for asymptote, over here you would have +2, right? So on the one hand, this is making your y values positive, but which would be actually considering just this, okay? Just this. But now when you consider, you also need to affect the x values. And so if you go ahead and affect the x values, and this is the hardest part to explain, see? Technically, let's start maybe like from the middle, see? So if we start from the middle, we know that the middle has a 0, 3, right? So you know that you have 0, 3 here, right? And you know that somewhere over here you have a, 0. And you know that it goes like this. Boom, and then boom, right? Something like that. You will have an asymptote over here at 2. Okay, that is all you know for the right side, okay? For the left side, because now you're doing the absolute value of your x values, because you have an absolute value inside, technically, like this x value right here, okay, this x value right here is going to be have the same y value as this x value right there. And so if the distance from here to here is, for example, 1 for your x, and from here to here is also 1 for your x, then these y values have to be the same because of the absolute value. Okay, so basically this x equals -1 is going to have the same value as the x equals +1 over here. This x equals, I don't know, I'll make it up, x equals -3, right? So I don't know, maybe somewhere around there, I'll just make it up, has to have the same value for y as the x equals 3 over here, right? And so once you realize that basically the x equals -1 has the same value as the x equals +1, and the x equals -3 has the same y value as the x equals +3 because of the absolute value thing, then it's basically sort of mirrored. And so you go boom, and then boom. And so here is your sketch. And so because, as I said, the x equals -3 has the same y value as the x equals 3, then if this is a, then that means that this is -a. And so now we are ready to sketch properly. See? I just really needed to go over the thing of how the absolute value is affecting, on the one hand, the y values when it's on the outside like this, and also affecting the x values when it's on the inside like that. Okay, so having that in mind, if you go ahead and sketch it now, I'll try to make it a little bit more fancy, but on the one hand, you still have a 0, 3 for y-intercept, okay? On the other hand, as we identified, you will still be following this path over here, see? So you're still going to be reaching that a. But because you can't have negative y values, this part here is really just going to go up top, right? It's just sort of going to reflect and go up top. And because you have an asymptote at -2, well, now that asymptote has to be up here at +2, okay? So it reaches a, and instead of it still going downwards, now it's simply going to go sort of upwards and have an asymptote at =2. See? So whatever, that's probably good enough. See? And so here, just to get full credit, I would be putting definitely a dotted line and a y =2. See? And now, because I identified that, because we have an absolute value on the inside, right? That means that, I don't know, this value here, if you take the distances equally, is also going to be this value here, this distance here, equaling that distance again. You have a point there. Basically, it's also mirrored on the y-axis. Okay, so the other way you can kind of think about it is that the absolute value is going to mirror. So absolute value mirrors slash reflects your graph. Okay, this is another way you can sort of try to remember it, which is actually part of the mark scheme. Here it says attempt to reflect f in the x or y axis. Okay, like technically, if you cover this side and you say, okay, try to reflect it, boom, it's going to show up on the left side, right? So you can kind of imagine it that way. There's a lot of different approaches. What I really needed to explain here, though, was the concept of absolute value. And so from here, because all these points are the same, then you know that this a value is also going to be somewhere on the left right here, right? So here you know you have a negative a, okay? And so now I can sort of try to eyeball my sketch, which would be something like this. So boom, and then boom like that, again with the asymptote, see? So just to really get full credit, I will be marking this point as negative a comma 0. This a, well, it's already marked, but I'll just put it as a comma 0. Here I can put 0 comma 3. I marked my asymptote. I'm good to go. See, so this would give me the whole 4 points. And yeah, that's about it for part A. See? Part B gets a little bit more exciting. And so part B, what they ask you to do is to find the possible values of k such that g of x squared equals k has exactly two solutions. So notice, it's not at least two solutions, it's exactly two solutions. So, what the heck does this mean? Notice, on the one hand, you need to square your um, function. See, so we will talk a little bit about what happens if you square your function, okay? But before we square a function, before we see how the numbers change and stuff, let's really try to understand what it means by exactly two solutions. And so if here, we will do the exercise not with it being squared, but just thinking that g of x equals k, where two solutions. Okay? And so how the heck would you even answer this? So, first things first. A long time ago, at some point with math, you stopped writing, for example, y equals ax squared plus bx plus c, but instead you started writing f of x equals ax squared plus bx plus c. And so why do I tell you this? Well, I tell you this to identify that f of x is basically just your y, see? And so from here, you need to see where do you have two solutions thinking in y. Thinking in y, see? And so I know this is like maybe not the most professional way to explain it, but I think intuitively it's going to make a lot of sense. So g of x equals k, where do you have two solutions? So you're thinking in terms of y because you have literally g of x equaling k. And so if you're thinking in terms of y, okay, this k value, imagine that k equals negative 3. Okay, if k equals negative 3, that means that at negative 3, you have a line going like that. How many solutions do you have? 0, because you're not touching your function at all. Let's imagine now that k, okay, and we're going to keep doing this until you really understand it, see? Let's imagine that now k equals negative 1. So if k equals negative 1, while you're cutting through here, are you touching your function at all? You're not. No solutions. But the moment you say, for example, I don't know, that k is whatever, like 1, see? So when k is 1, boom, boom, boom. How many times are you touching your function? Once, twice, thrice, and 4 times. So damn, here at k equals 1, you actually have 4 solutions. And so you gotta keep doing this and keep thinking, and this is the creative part that I mentioned earlier, where do you have exactly 2 solutions? And eventually, you guys, you will identify or see that you only have 2 solutions right above the horizontal asymptote. Because right above the horizontal asymptote, you can draw a bunch of lines that go like this, and all of these have only two solutions, unless you're crossing right at the maximum. If you cross right at the max, so right at max, it is only one solution. But anywhere below that, you are actually cutting through twice. For example, here you cut there and you cut there. Here you cut there and you cut there. And so clearly, above the horizontal asymptote, or in that small sort of area section, is where you have two solutions. See? And so for the answer of my sort of made up question, sorry for erasing all of that. Let me redraw it real quick, something like that. All right, cool. And so where does K have two solutions? In your unchanged, in your OG version, K has two solutions wherever you have that K, okay, is greater than or equal to 2, but less than 3. Okay? Now, that is for the original. See? Here they are asking for g of x and it's being squared. All right? So the same sort of exercise. On the one hand, I can immediately give you like the intuition that you just square your answers and you're good. See? So if in your original it was from 2 greater than or equal to k and less than 3, okay, you can just square your answers and you end up with 2 squared, k, 3 squared. So you're going to end up with 4 less than or equal to k, less than 9. Okay? So that is a sort of like quick trick you can use. Okay, you look at the original solution, you analyze it from there. If it's squared, you just square your answer as well. Bada bing, bada boom, it works. See? Now, that also works because of the nature of the function. Okay, it's not always going to be the case. I suggest you sort of graph and stuff like that, and etc. I think there might be special scenarios. I'm not sure if you guys see them on AAHL. So don't quote me on that. I'm not entirely sure. But at the very least, like analyzing the OG version of it can help you approach the problem properly. So on the one hand, you can look at the OG, then square everything, except for K of course, and boom, there's your answer. See? Now more intuitively, I do want you guys to see that when you square your function, what really changes, and the more I think about it, I think it is true that you can just square your answer and it's going to work every time. See, if it's squared here, it's just gonna, this is the thing, it's gonna change in proportion. See? It's like the same shape, just that it's bigger or smaller. So for example, you can draw like a cube, right? And then you draw like a bigger cube. And it's not that it's the same cube, but they are similar cubes. Okay, one of them is maybe 3 times as big. See? And so there's a bunch of relationships that come out of that, like how does the volume change? How does the area change? It's all in a nice proportion if the distances are all increasing at the same ratio. And so if it's times 3, the area changes in a very specific way. The volume changes in a very specific way. The distances change in a very specific way. See? And so all that kind of stuff, it's worth getting familiar with, especially for these types of exercises. And in this case, we're talking about a function. Okay, we're not talking about a cube, but my point is they're very similar. There are relationships that arise when you multiply all the distances by 3. See? So in this case, if you square all your values by 2, well, look at this example here. So here you have the red quadratic. See? It's a pretty standard quadratic. Look at it, enjoy it, right? If you go ahead and square it, which is the second example that I have here, see? So if you go ahead and square it, let's see what happens. Boom. So on the one hand, it's growing like a lot faster and this or that and etc. But let's really focus on when x is -1. Huh, interesting. So in the OG, when in the red one, see? When x was -1, y was 4. And in the new one that's squared, when x is -1, y is 16. And so, will you look at that? Basically, when you square a function, it's gonna grow in terms of y. Okay, it's not gonna grow in terms of x because your x values like practically stay the same. Like what really happens is that your y values get amplified. Okay, that's the big word I'm going for here. they get amplified. And so really, if you were to redraw this, all that's really going to happen, right? All that's really going to happen is that instead of having those dimensions here, you're going to have something that goes like this. Your horizontal asymptote will first of all be on 4, and your new y-intercept is not going to be 3, it's going to be 9, all right? And so if you analyze it, thinking it like this, well, it's pretty clear that after 4, after your y equals 4, right? After your y equals 4, from 4 to 9 is where you have all those double solutions. See? So here you have a double solution, here you have a double solution, here you have a double solution, but not at 9. And so that is why we write that the values of k that make it exactly 2 solutions is from 4, including 4, up until 9, but not including 9. Because 9 is right at the maximum, it touches only once. See? So you guys, I had a little bit of a monologue and blah blah at the end, just really trying to explain how the squared affects your functions, and just stick to the rule that basically it amplifies everything. See? It amplifies everything, specifically your y values. And so remember this example I just gave you here, and remember also how this one would change. See, you pass from an asymptote of 2 to one of 4, and you passed from a vertical, sorry, a y-intercept of 0, 3 to 0, 9, okay? So clearly you're just squaring the 3, you're squaring the 2, okay? So, that being said, you're here, if you square the 0, see, just in case someone's wondering, here all you would have to do, whoops, is square the 0. And so if you square the 0, nothing's actually going to change. And so if you were to like draw the other graph here, they would probably, well, technically I would have a y equals 4 like up here. Really, it would look something like this. Boom, it still touches at 0, and wham, somewhere at 9. See? Boom, and then somewhere at 4. See? And so here is like both functions plastered on top of each other. It would look something like that. All right? Again, stick to intuition. I hope you guys learned a thing or two in respects to the absolute value and in respects to amplifying and basically just squaring your function. Ladies and gentlemen, that is number 8. Not that hard, a little bit creative, but very doable. I'll see you around, and I hope it helped.